So Madhukar, we should start. Madhukar,
Okay,
please go ahead and yeah.
okay, sir. Sir, my audio is okay.
Yes, yes.
Okay, sir. So, respected faculty members, scholars, and participants, welcome to today's second session of 8th April. In this afternoon session, we have Sri Rahul Kaundal, who is taking session from United Kingdom. And so the second session has been shifted to 2:30 p.m. to suit the timing. So I take pride and deep honor to welcome him on this faculty development program, which he has volunteered to take the session on the pertinent topic of end-to-end call flow. Sri Rahul Kaundal is a distinguished telecom professional and CEO of ITELCOTECH, United Kingdom. He possesses extensive expertise garnered over 2 decades in the industry. He has worked across different geography, different organizations, from telecom equipment makers to top-notch telecom operators to evolve telecom network, including network design, operation, optimization from second generation to fifth generation technology. He is firm believer in the power of continuous learning and knowledge sharing. Rahul recently pursued studies in business management at Deakin University, Australia. This endeavor has equipped him with invaluable insight to drive value creation for stakeholders within the telecom sector. Drawing upon his wealth of experience, Rahul has spearheaded the creation of an exclusive e-learning platform, ITELCOTECH. This platform has emerged as a beacon for aspiring tech enthusiasts within the telecom industries, offering a comprehensive suite of over 40 courses covering a spectrum of existing and emerging technologies such as 5G, 4G, design optimization, KPI, Open RAN, slicing, private networks, NTN, ML, AI, and telcos, cloud, among others, to name a few. To date, ITELCOTECH has empowered over 3,800 individuals across 80 plus countries, fostering their professional growth and development. Apart from his work with ITELCOTECH, Rahul is a prominent public speaker actively engaged in discussions surrounding the evolution of technologies within the telecom ecosystem. His passion for innovation and commitment to drive industry advancement continue to inspire and influence professionals worldwide. So I think this short brief is not justifiable to his excellence in this field. Anyway, I invite Mr. Rahul Kaundal to take over the session. Please, sir, go
Thanks
ahead.
a lot. Thanks a lot, Mr. Sanjay. Yes, I think thanks for such a beautiful narration in the beginning. Yes, as you mentioned, I'm working in telecom industry for almost 20 years. And what I'm trying to do today is to, get that experience and just want to share it with you. That's the overall intent of today's discussion. I prepared some slides and we will just go through it. And I'll start sharing it just quickly.
You can see your screen, Rahul. Yeah,
Perfect.
we can see your screen. You can go to the slide mode. Yeah, yeah, yeah.
Great, great. Yeah, so as rightly said by Mr. Sanjay, so my name is Rahul Kaundal. I'm working in telecom industry for almost 20 years. And during this 20 years, I've seen the evolution happening from second generation to fifth generation, which obviously I think most of you would have seen. And technology now is advancing very quickly. We have seen now the discussions are going around 60 also. So what we are going to do today is basically trying to cover some of the key terminologies related to 5G, focusing on 5G. I've split this complete program into 2 parts. So we will have today the first part, which is more about the 5G architecture. Before going into the call flow, we'll just understand the nitty-gritties about the 5G. And then maybe the next session we'll have sometime during the end of this week, we will talk about the further how can we design and plan 5G, a little bit advanced level. So we will start with the little bit of basics, but we'll gradually go to the more intermediate and advanced level. Feel free to keep these sessions interactive. Feel free to ask questions, queries, whatever you have. And at the end, we'll talk about our learning platform also, where we are, of course, currently almost 3,800 plus tech engineers, managers, CTOs. We are upskilling them through our platform. Without any further delay, I'll start with the first part, and which is more about the basic, then quickly covering the architecture, then quickly jump to the call flow. The table of contents for this particular session today will start with the technologies, how it has been evolved. You primarily might be aware about the different standard bodies who are working behind evolving these technologies. So those are Third Generation Partnership Project and the ITU, International Telecommunication Union. We'll understand what exactly the need of 5G and what is the key deliverable. Why do we need it when we have 4G already in place? So there are certain additional deliverables which are there to be delivered by 5G. We'll understand that. Next to that, we'll get a little bit more detail, having a holistic view of having the evolved technologies, because we need some more efficiencies in the ecosystem. We need to meet customer demands, create new avenues. So it is the motive to be achieved from the two different perspectives. One is from the industry perspective, where, say, operators, they want to create some efficiency in the network so that they can make it more, the revenue-oriented industry, more profit-oriented industry. Second is from the customer perspective, from their experience, how can we make it better? How we can generate new use cases? We are talking about the virtual reality, augmented reality, autonomous vehicles. So how can that be delivered? So we'll talk about all these different use cases. But before delivering that use cases, we need to understand what exactly need to be changed in the network, because there are certain stringent deliverables that are defined by ITU and 3GPP for 5G. And to deliver that, we have to make different advancements in the network. We'll talk about that. Now, before we go towards the call flow, and what I understood, probably you would have already gone through these different key terminologies and concepts, but I will quickly touch base upon the protocols at the air interface and the architecture, how we are having a flexible architecture in place for 5G. We'll understand in the air interface the advancement that has happened, what kind of flexibility has happened, the way we transmit and receive the information over the air, it has made more flexible with 5G and more efficient. We'll understand in a frame structure about that. So next would be, before again jumping into the call flow, it is important to understand how a device connects to the network. So I will explain it in a very layman language, that how when you switch on your phone, what actually happens. What are the key transactions that happen between the device and the network, be it related to synchronization, and then after, once it is connected, there are multiple other techniques which will be used, such as modulation and multiplexing. Thereafter, we'll understand the call flow, the initial access. It means whenever the device is switched on, or there are certain other procedures during the initial access. And the second is when somebody is accessing to the internet, what kind of different flow of the messages between the different nodes of the network. So we'll understand that. In the end, we'll talk about a little bit about why 5G is important, why all operators across the globe, they are working on it. It is because it is going to contribute to the GDP and the economy heavily, and we'll understand a little bit about that. So these are the key concepts we are going to talk about today. Starting from the basics, a quick one. I want to make this session, first of all, interactive. So please feel free to stop me wherever you feel there is a question or you want to keep it for the end, just keep it for the end. It's completely up to all of you. So we all have worked in telecom industry, for many, many years. We have seen the evolution that is happening in technology. The major key factors which is defining the technology, there are many other factors also, but we are focusing on the major factors. One is what kind of data speed, if we talk about the data, what kind of data speed can be provided by each technology? If it is kind of the advanced use cases, which is catering towards a lower latency, what kind of latency can be delivered by each technology? And when we say latency, it is the delay in a layman language. And what kind of services that can be provided by all of these technologies? Why do we need it with time? So 1G, of course, this is simple analog voice services, which was deployed in 1980s. Every technology we have seen have a advancement in a decade. So 1990s, we have seen 2G, which we call as a second generation or a GSM, Global System for Mobile Communication. This is something which is still in existence. The beauty of this technology is it is still here in existence after even 34 years of that. And the good part is it is catering to quite a good amount of voice traffic in the networks across different regions, across different operators. Now, this technology first was there for only digital voice services. Then 2.5G came in, which was more about the GPRS services, which was the data. And then there was a 2.75G, which was Edge, which was giving 384 kbps as a downlink speed. So at that time, when it was rolled out and deployed, it was more about the messaging or for the voice services, and then slowly MMS, and then some low speed data services, say for example, downloading the emails and all. Latency was very high at that point in time for 2G, 600 milliseconds. So it is not very good for having some kind of a real-time application. Then after it was 3G, which was rolled out in 2000. And again, this technology is not like day one, it is fully mature. 3GPP has kept on evolving the different specifications with time. So there are different releases, if you might have heard about it. So there are different releases that are time to time rolled out by 3GPP. And what it says is some kind of advancement is happening. Within 3G, in fact, within 2G, every technology, there are certain different releases that have been upgraded with time. And we'll talk about that. Now, in 3G, we have seen the maximum speed that was delivered is 42 Mbps. Again, this is more like a theoretical kind of deliverable. And in practicalities, there are multiple factors which defines what kind of speeds can be achieved or what kind of latency can be achieved, and we'll talk about that. So in 3G, we see that the latency has decreased from 600 to 200 milliseconds. And the focus was here to be a little bit of data-driven kind of network where the speed was good. You can do some kind of real-time kind of activities, streaming, but again, it is not really very good. If you go for 4K videos, probably will not be able to have that seamless experience. Then it was 4G in 2010, which was deployed, and theoretically, the kind of speed we can achieve with this is 1 Gbps. And if you see, the latency has cut down by half, which is 100 milliseconds. Now, here, basically, the broadband kind of services was delivered and is being delivered by 4G today also. And we have a voice over LTE also enabled in 4G, which is a kind of a high definition voice services. So basically, from the architecture perspective, what has happened is there is always two different kind of core networks, the voice and the data. So in 4G, what has been done is to get rid of the voice part of the network nodes in the data center, there we have seen that the voice to be carried on a data packets. And there it called as a voice over LTE, which is more like a data-driven kind of voice services. In 5G, we are basically seeing that rolled out and being rolled out by many operators. And the speed that can be achieved is 20 Gbps. This is at the cell level. So, whatever we are talking about, the speeds here are from the mast perspective, but it is not necessarily that we'll get 20 Gbps at the devices, because then there are multiple factors. Because how many users are there in a cell? What kind of radio conditions are there? And we'll understand that, these are the standards set, but to get these kind of results in the real network, it's not easily achievable. Latency has dropped down to 1 millisecond, and that is where the new use cases of 5G are emerging when we talk about the ultra low latency services, be it autonomous vehicles, robotic surgeries, and still things are evolving, things are changing. It will take some time, but the good part is things are slowly, gradually evolving in this ecosystem. So any question anybody is having at this slide, I'll jump to the next slide quickly.
I think proceed, sir.
All right, thank you. Okay, so we talked about the standards and specifications. So you might have heard about ITU and 3GPP. So basically, any kind of new technology that comes in, what kind of performance to be delivered, what kind of throughput, latency, and all these things which we have seen technically, those are the requirements to be achieved to simply say that technology as a 5G, 4G, 3G. Now, 3GPP is a governing body who actually make the different specifications in the reports time to time to define these different technologies. Now, 3GPP is basically having a different release time to time. I haven't captured that, but currently we are on release 18 and 19, which is like advanced stage of 5G, where new features are coming in, satellite communication we are talking about. So each and every release is having some kind of specification and advancement that is captured. So sometime if somebody wants to understand about where currently we are in terms of evolution of 5G, you can refer to 3GPP website and you can just go through the different release and advancements that are happening, be it related to radio, be it related to core network, and in between. Okay, so 5G, we know that, so I'll just quickly skim through it. So we have 3 key different deliverables that are there to be delivered by 5G. We have an enhanced mobile broadband. So we have seen in 4G, it's a mobile broadband services we are providing, but it's a little bit one step ahead of that, faster speeds, faster data rates. We have a massive machine-to-machine type communication. That means we are going to tens of millions of devices to be connected to a cell site. That kind of capability is there in case of 5G. If we talk about the lower latency, we have seen the latency of 1 millisecond that can be achieved with 5G. So what is the need of these different, kind of deliverables? If we see here, there are different use cases. You want to download some kind of cloud information nowadays where you have a humongous data is there. You want to download and interact with it. You need a faster data speeds in that case, in case of GBPS. That can be achieved. We have maybe multi-screen ecosystem somewhere, or at homes, multiple devices are there which are 4K videos, 3D videos, ultra high definitions that can be supported by 5G. We have seen that in 4G it can be supported. It's not a case, but as we get into commercialize of the network, be it a 4G, the number of users that are coming in is more. As it is increasing, your kind of capacity is getting shared, kind of data speeds for user perspective getting decreased. So that's why we are going towards the evolving technologies so that we can provide these kind of services seamlessly in a better way. Augmented reality, AR, VR, that's what we can enable using 5G. Industry 4.0, 5.0, we are having a different industries where telcos are collaborating with, be it healthcare, be it utilities, to get some or create some kind of value through leveraging 5G. Self-driving car, mission critical application, robotic surgeries, things are evolving. There are many new use cases that are emerging, and different teams and companies, vendors, they're working on it. Looking at smart city, again, connectivity is paramount. If we have a robust connectivity that through wireless, which is easily accessible to the devices, then it's possible to have a smart cities enabled. Okay, so key capabilities, just a quick recap if you might have known about it. So we have IMT Advanced, which we term as a 4G, and we have IMT 2020, which is 5G. Now, just a quick recap who's working in 4G. In terms of 4G, at a cell level, we have 1 Gbps of downlink speed. So it is from the site level. It doesn't mean that a user will get 1 Gbps. It can get 1 Gbps in an idle scenario, in a lab condition, only one user with all kind of set parameters and configuration in the site. It can achieve 1 Gbps, more of a theoretical part. Similarly, in 5G, again, in a lab scenario or in an idle situation, from the device, from the mast, we can get 20 Gbps. But at the user end, if it is only single user, then it is possible as the number of users keeps on increasing. What the target that has been defined by ITU is 100 Mbps at the user level. So one is at the cell level, one is at the user level. So whenever somebody, when you talk to somebody about the data speeds to be achieved by 5G, mind it, we are talking about two different terms. One, what can be delivered from the cell site or the mast, and what can be leveraged by the user, which is 10 and 100 Mbps in 4G and 5G respectively. Spectrum efficiency, it's going to be better in 5G because what we are going to do is we are adding more efficiencies, we are adding better architecture, we are adding more flexible air interface. So when we say the spectrum efficiency, we are simply saying, we got 10 megahertz in 4G or 20 megahertz in 4G. How much bits per hertz per second we are sending? And in case of 5G, what we are trying to do is we are having a higher modulation schemes, we have a better multiplexing, and we are trying to send more bits per hertz per second. So that's the kind of efficiency we are measuring. And we are saying that there we are increasing these kind of bits to be transmitted is 3 times in case of 5G as compared to 4G. And there are multiple factors that drive it. It's not only just having the flexibility in an air interface or in a different nodes architecture. It is also about kind of new antenna systems we are using. We'll talk about that. Mobility, in case of 5G, the ecosystem is developed in such a way that any fast mobility devices, it can cater to up to 500 km per hour. Latency has dropped down by 1/10 as compared to 4G, very stringent latency. And this is where the major role of the architecture, flexible architecture comes into the picture. We'll understand that. Connection density, again, when we talk about the massive IoT, millions of devices can be connected with 5G at a cell site. Efficiency, now network efficiency, what we are saying is we are going to increase by 100 times as compared to what it is in 4G. But interestingly enough, when you look into the 5G devices, radio modules, their power consumption is even higher. But what we are measuring here is the 5G box, even by having maybe twice the energy consumption as a 4G box in the layman language, but this 5G box is generating maybe 10 times higher traffic as compared to, or throughput as compared to the 4G box. So in a way, that's where we are saying that per MB, per GB, whatever we are generating the traffic, for each MB, the kind of consumption of energy in case of 5G, it's much lesser as compared to 4G. So it's more about the kind of comparison so that you can correlate, where 5G is right now when we compare it with the legacy technology such as 4G. Some design goals. This is more from both from customer perspective as well as from industry perspective. So it gives a more flexible architecture. It opens up a new avenue because now we have new use cases. We have low latency. We have a higher capacity. We have massive IoT. And by delivering these use cases, what we are going to do is we are going to generate a value. We are going to create a value for the stakeholders, for different industries, for manufacturers, for automobile industry. There are multiple industries where these kind of communication system can be leveraged. Mining industry. So we'll talk about these different use cases in a little bit more detail at the end. Also, we have seen that we are not restricted only to a voice or a data services now. We are going to leverage machine-to-machine communication, human-to-machine communication, human-to-human communication. What kind of communication it is there? All can be catered by 5G. The networks will be made more intelligent because in case of 5G, what is happening is we are going towards a little bit of openness of the network. Right now, we have seen in the networks, it's more about tightly coupled with the proprietary hardware, which is provided by some of the operators in some of the vendors in the operators ecosystem. We can call a few names, Nokia, Ericsson, Huawei, ZTE, all are there. So they have their proprietary ecosystem, where it's very tough to incorporate the intelligence. But as we are going to evolve the overall ecosystem, we are going to open up these kind of proprietary ecosystem. We are going towards commercial off-the-shelf hardware. We are going towards adding up the machine learning and AI in telecom to make it more intelligent. And we'll touch base upon that. So these are the different design goals, which is obvious with any new technology to be incorporated. Now, talking about the use cases, we have seen, for human to human, be it related to voice or data calls or video streaming, or whatever it is, either related to human to machine when we talk about ultra high definition, 4K videos, healthcare monitoring, remote surgeries, these all different kind of use cases that can be catered by 5G technology. And if we talk about the different industry, be it manufacturing, recently I have read one article where it was BMW, I think the company, automobile industry, was talking about achieving 8 millisecond of latency in their factory, in their manufacturing setup, to have a kind of more efficient production and faster production because of supply chain is impacted in case of automobile industry where there was a delay in supplying the cars. So they were trying to speed up whole this process where they were leveraging 5G to achieve lower latency services. So kind of giving an example, there are different areas where we can leverage different use cases of 5G and create some value. So it depends upon maybe tomorrow some industries, telcos will reach out or they will reach out to telcos and they will talk about having such kind of efficiency in their ecosystem by leveraging 5G. Okay, so let's get into a little bit more deeper into the technical aspect. Looking at the 5G, I'm pretty sure you must have seen, there are 3 key sub-networks in any telco ecosystem. We have the radio access network, which we call as a new radio in 5G. We have the base station, the mast. Then we have the data center or core network, we call it. And then third is the transport network, which is connecting all these different nodes. So currently in 4G, we have a kind of very tightly coupled hardware, software placing at one location, be it a radio or be it a core. Now in 5G, from the architecture perspective, what is happening and what is changing is we are going to the baseband unit. If you have seen the baseband unit, we are going to disaggregate that. Now, it is not necessary to have that disaggregation. In fact, 5G can be deployed without having that disaggregation, with having only one baseband unit. Let me see if I have another slide on. Okay, this one. Let's go into this one first. So this is current setup we have in our ecosystem in telcos in India. We have the baseband unit, we have the radio unit, and we have some fiber cable in between that. And there is a transport network, which is a backhaul, be it a microwave or a fiber, and coming back to the data center or core network. Now, these boxes, the baseband unit, it's more like a black box. It's a proprietary box provided by, say, Nokia, Ericsson. They have their box, they have their own setup of software on it. You cannot use this box for some other functions if you want to. And you have to only run the software which is provided by that particular vendor. Now, that is one kind of a foundation for operator. Second thing is, as the technologies are evolving, are we going to use it, the 4G baseband unit for 5G? Hopefully not. In that case, the vendor will come back and say, change this box, you have to upgrade it, you have to pay money for that, pay money for hardware, pay money for software, pay money for maintenance, and the operator is screwed for many, many years. So in 5G, what the things are happening is basically we are going towards more open kind of ecosystem where this proprietary hardware, what we are trying to do is we are saying that, okay, let's buy one hardware or a chassis from a vendor neutral, kind of an ecosystem. Say HP, Dell, they have some kind of box hardware, which we'll procure, and we'll just put a software which will work as a baseband unit. So, and that particular box can be used for some other purposes also. So let's take one example. We are saying that, first of all, let's disaggregate this baseband unit. Why do we want to disaggregate? And before that, what is the functionality of baseband unit? Because the baseband unit is processing all the information, whichever is coming from either from the core network or coming from the user device. Now, the processing are of two types widely. One is a real time, one is a non-real time. When we say real time, non-real time, the difference widely is anything which, when user connects to the network, there are certain kind of a user information which needs to be transacted quickly. Another is in the background, there is some collection of information which we call as a control plane. That is something which is not real time, right? So we want that, okay, let's cut this baseband unit into two parts and put a real time thing in one box and keep it closer to the site, and take rest of the non-real time kind of functionality in another box, which is a CU, is a central unit, and put it a little bit far away from the site. Okay. What is the advantage of having this disaggregation, you may ask? One is the keeping some of the functionalities at a central place for multiple sites where it can help. It can help in having a pool of resources for multiple sites. Now that control functionality, which was embedded in one black box, which was only serving for this particular site. Now what we did is we made a pool somewhere at a central location, at a hub location between the core network and the site. And there we are going to make a pool of those resources so that whenever any site, maybe 5 or 10 sites are connected in a pool, whenever they need those resources, we can just provide it from the pool. Now, what is the advantage? Now, this pool, you need not to have a hard capacity, the kind of 10 times capacity as compared to what we have here for 10 sites. No, you may need a 5 times of that. You are saving on the capacity part, which is one of the costliest asset for any telecom. 60 to 70% of the capex and opex that comes from the radio side in the telcos. And if we are going to create some kind of value by having these pooling of resources, we can save on money. It's a big saving that can be created. But of course, it's not very easy to achieve. Now, this segregation part, we have a distributed unit we keep at a cell site. We'll say, real-time activities, you will take care of it. And we have a centralized unit, we'll put it somewhere at a hub location. Now, in case of 4G, we have simply a transport connectivity, which we call as a backhaul. In case of 5G, in case of this disaggregation network. Now, let me just clarify one thing. It is not necessary to have a disaggregation in 5G. It is not like only 5G will work when there is a disaggregation. In 5G, the radio can be, or the RAN can be looking like similar to what it is 4G, but then we will not be able to have those kind of use cases which we are talking about in terms of lower latency and having some efficiency. So that is a little bit, tricky to achieve. So this is like, I would say, is a 5G complete flexible architecture, which should be the target and which is the target for each operator, but it is not possible to achieve maybe in a one go. So maybe they'll go step by step. So this is one part of it, disaggregation of the access network. Now, the backhaul, which we have currently, you have microwave links, the fiber that is connecting all the sites back to the core network. In case of 5G, when we have these kind of edge locations or regional locations or hub locations, we have a kind of a different terminology that is coming in terms of transport network between this regional or edge location to the cell site. And this is termed as a mid-haul. Now, mid-haul has some kind of stringent latency requirement as compared to the backhaul. The reason is the kind of the kind of central unit functionality, though it is not real time, but it is not suitable for a larger lag or delay. So as compared to what is there in the previous backhaul. So we have some kind of specifications. We'll talk about that in subsequent slides in terms of mid-haul. But what we are trying to show here is the backhaul is now divided into two parts. Basically, one is the mid-haul and second one is the backhaul itself. From the core network perspective, we are going to pick some of the functionality from the core network or the data center and put it in the edge location, so that what is the need of this? Because we want that user plane functionality from the core network perspective that is quickly being done at a hub location rather than going back all the way 100 kilometers back to the data center or core network. And then there are different other key terminologies which we are going to talk about today, which are the building blocks of the 5G. One is the flexible frame architecture or the structure in case of air interface. We have a wider bandwidth in 5G. We are going beyond the kind of 10, 20 megahertz kind of carrier bandwidth today. We can go up to 100 and 400 megahertz in millimeter wave. We'll talk about that. We have advanced antenna techniques such as a massive MIMO or beamforming as we are going towards the millimeter waves or a higher frequency bands. We want some kind of advancements in antennas which can increase the gain, which can compensate the coverage loss because of the millimeter wave frequency bands. We'll touch base upon that. The edge computing, the software-defined networking, the virtualization, all these things, what they're doing is making this architecture more flexible end-to-end. So this is more about, the difference between the architecture overall if we see in 5G. And 5G, when we talk about the radio part, it is important to understand that what kind of disaggregation that is happening. And the disaggregation, which I was talking about, the baseband unit, there are certain different functionalities that is being catered by the baseband unit today in 4G. In case of 5G, we are going to disaggregate. We are going to just cut it into two parts. So no need to remember all these different layers, but what exactly these things are doing is, just want to give you a brief about it. So we have a layer 3, which is the RRC layer. Now, layer 3 is the main connectivity towards the core network from the base station. And below that, whatever is happening, it's happening at the base station. And that is not going back to the core network, but it is the RRC, which is actually, selecting a particular network or, making sure that user is moving from one site to another site or one location area code to another location area code or connecting to the core network. That is being taken care by layer 3. And layer 2 is more about the QoS handling or security part. Now, if you see this particular box, there is no real-time activity that is happening. What is happening? Okay, a user connect to the network. He wants to just get all the authentication and everything to be done. Okay, that's fine. That is anyways, you don't mind if you switch on your phone and it'll take 2 milliseconds extra. You don't mind it, right? But once you're talking or streaming something, you're doing something real time, then if you see a buffering happening, you will immediately observe it, and that will impact the experience of the customer. That is the reason we are going to put such kind of functionalities, which is embedded in a DU, which is a distributed unit, closer to the site, at the cell site. But rest of the functionality, which is not real time, we'll just take it away from there and put it in somewhere at a hub location, maybe a few kilometers away from the site. Now, if you guys are a little bit curious about it, let me just give a few more glimpse about what these things are doing, basically, just an overview, brief overview. So anything which is coming to the antenna, we have a analog EMF waves, which is converting to the digital form, time to frequency domain.
Rahul.
Yeah,
Rahulji,
that. Yeah.
Rahulji, there'll be a raise hand if you want to take the question.
Oh, yeah.
I
Please. Oh, sorry,
so
I didn't see
Jaswinder
that.
has just raised a hand. Dr. Jaswinder, in case you want to ask any question, you can open your mic and speak. Please go ahead.
So can you please explain a little bit more regarding this 5G protocol stack?
Oh, yeah, of course. I would love to. Yes, why not? Right. Okay, sure. Okay, so talking about the protocols, we are saying that the protocols are basically, there are layer 1, 2, and 3. And I'll just go back to the previous slide. So we are saying in 4G, we have all the layer 1, 2, and 3, that functionality is embedded in a baseband unit. But in case of 5G, we are disaggregating that. And what are the functionalities we have seen? Say, whatever the information that is coming from the mobile towards the antenna, that is, those are the RF waves, those are the electromagnetic waves. Now, those analog waves needs to be converted into a digital form so that the processing can be happened at a layer 1, 2, and 3. Now, this information when comes converted into a digital form, and then there is time to frequency and frequency to time domain conversion that is happening. That is happening at the radio module itself. Now, this radio module can be at the top of the tower. It can be just put in the box somewhere at the bottom of the tower. It can be anywhere. But what it does is basically for every different frequency bands, what kind of frequency bands we are using, we are having the separate radio modules for that. It is a frequency specific. So say, for example, if we have 4G technology, we have two different carriers, say, for example, 900 or 1800 megahertz band, we might see two different radio modules in that case. No, those radio modules would be connected with the antenna directly through a jumper cable. Now, once this information, once it's converted to a digital form, it will come down to this box, which is a distributed unit. In case of 4G, it is a single unit, which is baseband unit. The functionality mostly remains same in case of 4G and 5G. Now, when this information comes from the user, come from the antenna to the radio module, come to this box will make sure a couple of things. Now, what are those things? It will ensure that what kind of modulation that can be used. Now, we'll talk about a little bit about the modulation in subsequent slides. So what we are trying to say here is if what kind of radio conditions that the user are in, if it is good, we can transmit and receive more bits per hertz in that case. Now, it means that we are sending more data and receiving more data within the same kind of resources that are available in the air interface. And there are different modulation schemes. So I'll explain it in subsequent slide in very detail. But if the radio conditions are good, this particular box will quickly check that and quickly say that, we have a set of resources available with us. Now, this user is in a good radio condition. And if he needs, say, for example, 10 Mbps of speed, probably he needs only four different kind of sub-resources or resource elements to be given to that particular user quickly. So it's a real-time activity. Any site is having multiple users connected with it. So there is a base station scheduler. What it does is it sends that what is the requirement of each user, depending upon the services they are using. And on the basis of their radio condition and the services they are using, quickly, this particular device will select a modulation scheme for that user and start allocating the resources on the go quickly. Then there is a rate matching and coding. Now, what exactly this is? Say, for example, you want to send information from the user device to the base station or vice versa. We have to ensure that whatever the information we are sending, it is being received properly at the receiver end. So how do we ensure that? We have a coding rate for that. If we say that the radio conditions are really very good, whatever the information we are sending, we know we don't need any kind of interleaving bits in that information to get it decoded accurately. So that means you have a better coding rate in that case. But what if there is some kind of interference in the network? In that case, whatever information we are sending, we send few bits, but it is not received appropriately. So we resend it. Then maybe it is not received again. Then we resend it, but there is a mechanism for that. And that mechanism, widely we call it as an error detection and correction mechanism, which is being derived by two terminologies here, which is a hybrid automatic repeat request or automatic repeat request. So what it widely does is the receiver will keep on sensing, did the information that has been received by transmitter, it is received appropriately or not? If not, then they'll say, no, I haven't received the information appropriately. Then what the transmitter would do, resend it again. Then it resend it again. So there is some kind of configuration or definition we send in the base station that, okay, if the receiver wouldn't receive this information in one go, okay, repeat it for 4 times. Or repeat it in such a way that only send the information which is missing or not received. Just send only that one and combine it with the upcoming packets. or bits. So this whole, kind of transactions that is happening, it's more to ensure that information is seamlessly received at the receiver end. So these kind of all real-time activities are happening at a DU or a distributed unit, which is catering to layer 1 and layer 2. Now, layer 2 is having, many other different protocols also, PDCP and SGAP. But why we divided them? Because these two different protocols are not real-time. We don't need it to be real-time quickly to be acted upon. Whereas these things, if it doesn't happen, your communication will break. If, say, for example, the receiver didn't receive the information and just the transmitter didn't send it again because we didn't set these definitions, in that case, what will happen? The connection will break. So we don't want that to happen. We want this connection to be, seamless across their communication when it is happening end to end. So whatever the scheduling, the kind of resources to be allocated to the users to have a error-free communication between the user and the network, that is to be taken care by distributed unit with layer 1 and upper layer 2. Now, when you talk about the layer 2 lower layers, it is more about the header compression or security or the QoS handling. Now, the QoS part is something which is incorporated exclusively in 5G and radio. And the reason is, one reason is because in 5G, when we talk about the lower latency services, we have seen that in case of 4G, there was a QoS, but that QoS is more from the core network perspective. We have a QCI and the ARP, which is QoS class identifier or allocation and retention priority. Now, what that does is that set a user priority preempted, but from the core network perspective. Now, in case of 5G, what is happening along with those definitions in the core network, we have a settings in the radio network also, where we'll just ensure that there is an end-to-end mapping of this QoS flow. So if we have a lower latency user, again, going back to the example of that BMW customer, say, for example, or factory, they want a very low latency kind of communication. In that case, we'll label that communication, those users, with a certain set of QoS, which will be preempted as compared to other users. Now, the layer 3 is the most important layer when we talk about having a connection towards the core network. So you might have heard the RRC, the radio resource control. It's an idle or a connected mode. And before that, even when we go to the call flow, you will see that how important the role is of RRC to get this connection established initially. Now, that is a kind of a higher layer, which is connecting the user, going towards the core network, getting it authenticated, ensuring that whatever the information the user should know about the network that is there is a paging, there's a mobility that user will move around across one tracking area code to another tracking area code. That is all being taken care by layer 3. So layer 3 is more about setting up that connection, but beneath that layer, we'll see these kind of all these different functionalities that are happening to make this connection seamless. Within few milliseconds, everything will happen. So that is the kind of, if we compare it with 4G, we will see the disaggregation is one advancement, and second is the introduction of the QoS related protocol, which is SGAP. So I hope this will be helpful. If you still have any question, anyone, please feel free to ask, and I'll jump on to the next one after that. Yeah, if somebody has any question here.
You can proceed, sir.
Thank you very much. Okay, we are talking about the transport network, when we, please, yeah. Anyone?
So in case of 5G networks, so particularly MMTC type, massive machine type communication. So
Yeah.
here, all the devices, are they connected directly to the new radio device or station? Are they directly connected? Because 5G is a licensed spectrum. So does it allocate a new channel or licensed channel to all the devices?
Yeah, so very good question. So basically, I'll just correlate it with 4G. So normally what we do is we have, say, for example, 20 megahertz of 4G band. And what we do is within that 4G, within the 20 megahertz band, we have a possibility of either using a guard band for IoT services or using a narrow band within that 20 megahertz, say, for example, 200 kilohertz, just for IoT purposes. Similarly, in 5G, if we have a wide, whatever the band we have, the user will directly connect to the base station. To answer your question, it will be connected directly to the base station, and it will be using the band which is allocated to the telco. And the telco has two options. One is either telco will use the guard band for this IoT services, or it can use the band within that allocated 20 megahertz, 50, 100, whatever is allocated. Within that band, it will just have few subcarriers which will be allocated for IoT. But yes, it will be directly connected and it will be a part. It can be a part of this allocated spectrum or maybe the guard band.
So, sir, that means based on the data type what the channel is carrying, so that channel will be allocated. Because in some channels we are using high amount of data like video streaming and etc. But in case of machine-to-machine communication, the requirement of bandwidth is not that much.
Absolutely, absolutely, absolutely spot on. Yes. So in that case, that's why we are going to just allocate fix some of the subcarriers just for IoT purposes, which is not going to impact the capacity for overall, spectrum band for other services, as you said, for broadband services or for latency services. But we'll just take small subset of the whole carrier bandwidth for IoT services. And yes, it'll be connected directly to the cell site.
Thank you, sir.
Welcome. Okay, so transport network, because whenever you work in the network, you will see the transport is one of the important underrated subnetwork in telco. If something happens in terms of network operations, the culprit is transport network. So we have to make sure the transport network is intact. So what is happening in transport network, as we are disaggregating the radio, as we are disaggregating the core network, we are ensuring that we have a kind of connectivity which is robust enough to achieve that kind of lower latency which we want to achieve at a user level, at a access level. How do we achieve that? We have a kind of certain set criteria defined by, again, a standard body that they are saying, if you need to achieve 1 millisecond here at the user end, you should have some kind of stringent requirement at a mid-haul and the backhaul. It is not like what you used to have in 4G, because then you cannot achieve the lower latency of 1 millisecond or higher broadband speeds. You have to take care of higher capacity, because it is the pipe which is carrying all the information back to the data center. If we do everything at the radio end but don't upgrade our transport, it's useless in a way. So that's what we are showing here. We are saying, if we have to achieve some kind of higher capacity, lower latency services, we need to ensure that the mid-haul, which is the connectivity between the distributed unit and a central unit, we have a good enough capacity there. We have a lower latency kind of possibility there, and it should be somewhere. This is again a standard, 200 kilometers. But again, 200 kilometers, possibly nobody is going to deploy it in such a scenario. It will be few kilometers from the cell site where we have this edge location or a hub location, and then we have the backhaul, which is carrying the massive amount of data. That's why we have a higher capacity and even not very stringent latency in that case. So this, I think, will give a better picture when we talk about, the flexibility, the architecture, the kind of latency that we want to achieve. Now, let's start from here. We have 3 key services. Now, each 3 services has some kind of deliverables. We have lower latency. We are saying 1 millisecond to be achieved as per ITU, 0.5 millisecond as per 3GPP. Now, for broadband services, latency is not that much concern. 4 millisecond is okay. And for machine type communication, 15 millisecond is good enough. Now, how do we achieve that? How do we achieve precisely for low latency services? We are saying that, okay, let's do some disaggregation, which we have seen. That kind of disaggregation we have seen at the radio end. What we are doing is we are putting up a radio unit or a distributed unit at a cell site and taking some of the functionalities a little bit far away. And what we are also seeing, I'll talk about the UPF, just remember the name so far. I'll talk about all these different nodes from the core network in the subsequent slides. But what we are saying is when we are talking about the low latency services, it need this information from this particular user for this particular slice doesn't need to go all the way back, the 500 kilometers to get it processed. No, we will have a UPF just at the edge so that it'll be connected directly to the internet or maybe to the server to get it processed immediately so that we can achieve that kind of latency. What about the broadband services? We don't mind that if we have certain functionalities far away, we have the requirement of 4 millisecond. What about the machine type communication? It is a kind of a similar setup what we have today. We have a radio at a site. We have the backhaul all the way going back to the core network or a data center, which is miles away. And then we have everything processed at a data center. So that is something we can see in achieving these kind of different slices or functionalities in the network by having these kind of flexibilities. Again, achieving these kind of flexibilities in network, it's not easy. And probably slowly, gradually, this is the end target for any operator today. None of the operator are actually deploying such kind of scenario because, of course, they can't simply deploy it in this scenario because their legacy network is such that, which is huge in such a setup that you can't immediately transform the whole network. But this is what the target of each and every operator going forward is. Okay. As we talked about the radio, we talk about transport. Let me talk about the core network now. Let's consider an example. We have a device which we switch on first time, how it is going to interact with the core network. So let's understand that in an easy way. And what I'm going to talk about here are two different planes. One is a control and the user plane. I hope you guys know about the control and user plane, but if not, the control plane is more about having that kind of transactions happening between the device and the network to establish the connection and to maintain the connection and to get some useful information from the user about its radio conditions and what else. User plane is more about the actual data which is being transmitted between the device and the network and vice versa. So I picked up the phone, I switched it on, say, for example, it's still in a control plane. I haven't reached to the stage where I want to, open my browser. I want to do some kind of chatty application. I want to download something or I want to make a voice call. So before that, I switch on my phone. It simply goes to the nearby base station and that base station and then further talks to the first node in the core network, which is AMF. Now, this AMF, if you are well aware about the 4G network, core network, it is similar to what the MME is. So AMF is basically, no need to remember the names so far. Anyways, I'll share the details later on. But what it does basically, any network has to ensure that whosoever is coming to the network, that particular user is legitimate or not. Can this user be authenticated? What kind of services it is asking for? Is this user has that kind of services, he has paid for those kind of services which he's asking for? Or is this user in roaming in a home location? If it is in a roaming, I mean, is he allowed to use the services? So all these things will be checked first of all. So authentication is the very first thing to ensure that this device, this SIM card, which is trying to connect to the network, should I authenticate it? AMF is the node which will confirm this thing. Now, for authentication, AMF will then talk to another node. Again, no need to remember these big terminologies. I mean, just understand it, what it does basically. So AMF will talk to UDM, which is a kind of a data management system, and AUSF. Again, it's an authentication server. Now, these two nodes have a subscription related data for individual subscribers. Now, this user, X user, is coming to AMF, and AMF will check that the X user is here. Do you have the credential for this particular user? Can I authenticate it? And so AMF, in conjunction with UDM and AUSF, will say that this user is legitimate. Let's authenticate it. Okay. Once it is authenticated, it has to ensure that the kind of services it is asking for. Can he avail the services which he's asking for? Maybe he's asking for the data services. But did he pay for that? Did he has subscribed for that? Okay, he has subscribed. Okay. What about if he's in roaming? Is he allowed to do roaming? Don't know. How do we check? Okay, check with PCF. So AMF will go to the PCF and say, okay, he's allowed to use the services in roaming. Okay, perfect. Once that is done, then there is more about the signaling data, which is, the SMF is a node which is basically taking care of the IP allocation to the user. So here, as you understand, for any networking part, there should be a IP allocation to each nodes, like end to end. It's a user and then the core network nodes. And interestingly enough, let's take one example. Say, for example, you moved from one location to another, you landed maybe a different location, and you just switched on your phone, and you didn't latch on to 4G or 5G in this case. And the reason could be maybe that operator who is having a set of IP allocated to the users that has been exhausted. So you as a user use a device, you didn't get a new IP from the operator in that case. And this has happened in a real world scenario. So maybe you don't latch to 5G in that case because your UE did not have allocated IP by SMF because IP pool is exhausted. So anyways, so that is one example which I'm showing, SMF is allocating the IPs to ensuring that communication to be started and continue further. Now, this is the user plane function, basically, where once user is connected, he is now the device is on, everything is on, he wants to just make a call or he wants to make a data session. This is where the UPF comes into the picture. What this user has a kind of priority, is it preempted? That is being taken care by the QoS. What kind of QoS that is allocated to this user? Is a gold-plated customer, is a silver-plated or a normal, or maybe he needs some kind of lower latency services, so he needs to give in a better QoS in that case. So all these different kind of settings to be provided by UPF to the user, so that the communication that is happening back to the gateway or to the internet, that will happen according to these kind of settings in the network, and UPF will ensure that now the actual data that is being transmitted, now the actual information bits that is being transmitted between the user and the network. Now here I'm just showing these 5-6 key nodes, but in 5G there are many other different nodes which are there in terms of enabling different kind of functionalities. Say for slicing, we have some different nodes and functions. But here, just for a basic understanding, like how the connectivity looks like and what are the key nodes in 5G core network, I'm just focusing on that at this point in time. Any question anybody is having here, so please feel free to ask. I can't see any hand raised, but yeah, please feel free to ask. Yeah, anybody? Yes, please.
Sir, actually, what sort of protocols are used to realize all these functionalities?
That's a good question. So in case of core network, what we have seen earlier, those are the protocols that are at the radio level between the base station and the user, which is there. Now for this one, there are different protocols which are basically starting from the NAS signaling, which is from user to the AMF. And then we have the GTP. It's the similar kind of the protocol what we have in 4G. We have a GTP. We have similarly when we go down in the lower layers. I think it's the same layers what we have in 4G. I have one slide. We can talk about it, but it's the same protocols what we have in 4G. We have a GTP at the top, NAS, then GTP, and then we have other layer 2 and layer 1 at the physical layers.
Okay, sir. Thank
if
you.
I have that slide. Yeah, if you want, I can cover it in maybe in the next session. Yeah, but yeah, I can cover it. Yeah, I'll note it down. But I'm not covering it in the core network protocols. But yes, that can be done.
Okay, sir.
Anyone has any other question? Okay, so let's proceed. Okay, now when we talk about the call flow before that, let's understand, the basics about the frame structure. And if you know the frame structure of 4G, it'll be easy to understand the frame structure in 5G. Why to understand the frame structure? Because when we look into the kind of deliverables which we are talking about, the latency, the broadband, and all these different use cases, it comes down to the nitty-gritties of at the air interface, how we are allocating the resources. Now, in case of 4G, it's a 10 millisecond frame, which is actually carrying the information, and then it is subdivided into the subframes, and then subframe is into a slot. So any information in the time domain. So we have a time domain and a frequency domain. So any information in the air interface which is being transmitted, that is in the time and a frequency domain. So in a frequency domain, it'll be your carrier, which is the carrier bandwidth we are having. Say, for example, I'm just considering an example of 5 megahertz in 4G. So we have certain 5 megahertz band, which is subdivided into subcarriers. Now, these subcarriers are then being transmitted within a time frame of 0.5 milliseconds. And within this 0.5 milliseconds, we have OFDM symbols. So I'm not sure if you have gone through these OFDM symbols earlier. What normally we are saying is we are just trying to split the complete resource grid in a time and a frequency domain as minutely as possible. What is the advantage of doing that? Because it's easy to allocate these resources across different users if we just make it as small as possible. That is the best way of using the resources. If somebody needs only one small resource element, which is this rectangle square box, if he needs only one resource element, why do I give 2 or 3 or 4 by default? So let's make it as small or as efficient as possible by making them a minute level at a frequency as well as a time domain. So what we are doing is 10 millisecond is a frame. We have a 5 millisecond as a 5 megahertz as a frequency carrier. Let's divide them both in a time as well as in a frequency domain. So we keep on dividing that, and we just get a resource element. Now, these in a frequency domain, these 12 subcarriers, which is of 180 kilohertz, and in time domain, one OFDM symbol is termed as a resource element, and this complete grid, if you see, the 12 subcarrier and the 7 OFDM symbols 0 to 6, this is a resource block. So whenever we talk about allocating the resources in a time and frequency domain, we are considering the resource block as a resource kind of a terminology. So whenever we say, we have a 10 megahertz of band, how many resource blocks we have, we'll say, 50 resource block. How did we calculate that? This is how did we calculate. So we have a 10 megahertz here, say, for example, 5 megahertz, 10% of that complete frequency band, we are just keeping it as a guard band. The rest of the subcarriers we are going to just give for sending the information, and that is where we are going to make a resource block. Now, in case of 5G, what is happening? We are going one step further in 5G. In case of 5G, what we are saying is this particular frame, which is of 10 millisecond, which is divided into 10 subframes, we are playing further with the subcarrier spacing, and we are playing further with the slot, what kind of time slot we can use. And if you see here, in case of 4G, we have a fixed one slot, which is of the complete 2 mini slot of 0.5 millisecond, which is of one slot of 1 millisecond and 15 kilohertz we are using in 4G. But in case of 5G, what we are trying to do is we are trying to increase the frequency subcarrier and decrease the time frame. In a way, whatever the information we are sending in this particular yellow zone, it is similar to what we are sending here, but the only thing what we are doing is we are decreasing the time. Now, where does it help? It will help where we are trying to achieve the lower latency kind of functionalities. That's where it will play a role. So in a previous thing, if you see, we have a fixed slot, which is 0.5 millisecond, and in a time domain, and in a frequency domain, we have a fixed 15 kilohertz as a subcarrier. But in case of 5G, we have a different flavors. We can squeeze the time slot, and we can increase the subcarrier in a frequency domain so that we can transmit the same amount of data in a faster way so that we can achieve a lower latency kind of services. Now, these different subcarrier spacing, what we have, we call it as a numerology in case of 5G. And these numerology, the intent is only to create more efficient and more flexible way of sending the information. If we understand how this complete frame, how this works, we will probably understand the kind of call flow in a better way and kind of the kind of communication that is happening in a air interface in a better way. These flexibilities actually then helps to deliver the kind of ITU specifications of lower latency. Interesting part of spectrum. Before getting into 5G spectrum, let's go through the 4G spectrum. We have a different frequency bands that are available. In case of 4G, we have seen we have a lower frequency bands or we have a mid frequency bands. And widely, you would have seen we have sometimes the mix of both, but at least we have the lower frequency bands to provide the coverage. Now, why do we need mid-frequency band sometimes in 4G, or why do we need more than one carrier? Because we want to provide better data speeds. But in any of the carrier here, we have certain bandwidth which is fixed, which is 20 megahertz maximum that can be provided or given to any operator. Now, if you see the kind of chunks of bands that are available, the bandwidths that are available in case of 4G, very limited. We have maximum 75 in a lower bands. It means if we have 3 operators, we are left with only 25 megahertz maximum or 20 megahertz in that case. So we can have only one carrier of 20 megahertz, which can be used, and that too in a 1800 or 2100 band. But again, then you have to, there is a trade-off between coverage and capacity. So any operator would have at least these 700, 800, 900 megahertz band to provide a coverage to have less number of sites, because there how the cost, kept on piling up. So what they have is a mix of maybe the lower bands or maybe the mid bands in that case, in case of 4G. But in 4G, we have very limited bandwidths, maximum going up to 20 megahertz. And if you see all these different bands that are available, maybe some of the operators, they are deploying TDD to get a little bit more capacity. But in case of 5G, what we can see is in case of 5G, first thing is the frequency range is very wide. There are 2 different frequency range they have, came up with. One is frequency range 1 and frequency range 2. We call FR1, which is, we call it as a sub 6 gigahertz, though it is sub 7 gigahertz nowadays. What we can see is, again, the chunks, the bandwidths, what we have in these particular FR1 is still very limited. But if you look at the mid band, which is widely being adopted by most of the operators, we have quite a wider chunk of bandwidth available. And as per the standards, the bandwidths that can be allocated or can be used can go up to 100 megahertz in midband and can go up to 400 megahertz in millimeter wave. So the capacity would not be a crunch at all in 5G in terms of spectrum. The kind of spectrum we are going to get in 5G is humongous as compared to 4G. But then there is a trade-off between the capacity and the coverage. So as we go up high on the frequency, in a mid-band, we will get a wider carrier bandwidth, but we will not be able to provide that kind of coverage what we could provide with lower band. It means we have to deploy more number of sites, which is again a cost-extensive task. So there is always, the mix of both or mix of these 3 going forward in future when millimeter wave will be also deployed. So these kind of things we need to understand before, talking about, okay, how can we achieve 20 Gbps theoretically, but how there are multiple factors to achieve that. We have a flexibility in air interface. We have a wider chunks of bandwidths that only we can achieve those kind of, stringent deliverables. Now, this is something which is important to understand, because we just talk about the frame, but in that frame, in a time domain and in frequency domain, the carrier bandwidth, whatever we have many different type of information that are being transmitted. Now, these informations are important and are catering to different kind of procedures. So say, let's not look into it and let's talk about, whenever user want to talk to the network, device wants to connect to the network, of course, it needs some kind of information about the network in the downlink, first of all. It has some kind of broadcasting coming in the downlink towards the user to understand what network is all about. Okay, so we should have some kind of, initially some kind of information that is in the downlink to be provided to the user, maybe through the broadcast channels. And then we should also have some kind of synchronization, because we are doing everything in the air interface. Even few kilometers will have a few milliseconds of delay. To mitigate that, we need to have a synchronization between the device and the network. So, okay, we need some kind of resources for that kind of synchronization also. And what about that if we have more number of users connected to the cell site, how will that synchronization, after synchronization, how the cell site will ensure that appropriate amount of resources are being allocated to the user? Okay, that is also very important. So that we call as a scheduling. Okay, so scheduling is also very important. And then once all these things are done, we need to send an actual user information. But before sending the actual user information, there are many other things which needs to be done by the network and the device. So that all this information has to be sent in those frames which we just talked about in the frequency and time domain. So here, if you see, what we are saying is we have some kind of resources for broadcast channel, which is, if we see here, we have these light blue colors, and their position is fixed in this grid. And why it is fixed? Why it is fixed? Because user once connect to the network, it doesn't want to scan the whole 20, 50, 100 megahertz of spectrum. No, that is not the efficient way of doing the things. It just want to scan the particular place, particular spot in the grid to just quickly get the information about the network. So that's why the position of these important signals and channels and slots here are fixed every time. So user will switch on quickly, sense this information, he'll scan, decode the information from this particular subcarrier and this particular time frame, and get the information. What the information it'll get? It'll get the information about what kind of PLMN ID it is, what kind of bandwidth it is, or then only the user will sense, this is the network I need to connect to. This is what it is matching with my SIM card. What kind of different configuration that are there in the network, what kind of mobile country code, network code, all this information that is being, that is being transmitted in these three different signals and channels that is here in these boxes. So this is more about the initial procedure once we switch on or we come in the coverage of a particular site, and this is the initial procedure that happens. But once this procedure happens, we want to understand that how many resources needs to be given to each user. For that, we keep on sensing their requirement and radio conditions. For that, we have different channels, which is control channels. So again, no need to know these, learn about these big terms. Forget about that. The important part is to understand what is actually happening in the background. In the background, we want to ensure, each and every user would be given an appropriate amount of resources. Each and every user would be having a kind of mechanism where the error correction can be done. And if you remember, we talked about the layer 2, where we talk about the HARQ and ARQ, which is a kind of repetition of sending or transmitting the information sometime if it is not received properly. But how does user know about it? How does network know about it? All these things will be taken care by these control channels. Now, once that is done, whatever the different resource elements or these boxes, what are left with, those will be used for actually sending the data. So I'm trying to watch something, stream something, I need some resources. The cell site is having these many resources to be provided, maybe to me, to some other users who are connected to the site. All these leftover slots, or we call it resource elements, that will be allocated and shared across those users. That's why we say, when we have 20 Gbps, it is only possible when we have, very good radio condition. We have all these different, the white boxes, which is the shared channels for data purposes, that is allocated only to one user. Then only that is possible, which is an ideal scenario, which is not otherwise possible in a practical scenario. Now we have certain reference signals. So reference signals are basically to estimate when in your phone, when we talk about signal strength, it's basically the reference signals which once decoded by the user will estimate what is the signal strength. RSRP, that is the term we normally use it. I'll not get into that details. So these are widely, in a frame how the resources are being allocated. And it's always important for any engineer who's working in the telecom to ensure to provide a better efficiency, to ensure that these kind of resources are designed and planned appropriately. So this is what we just talked about. We have, we have a frame, we have a subframe. Within that, we have different slots in a time domain. We have a subcarrier in a frequency domain, and we have certain different functionalities and that is being delivered by these small boxes. We have a synchronization in a downlink. Similarly, we have a uplink synchronization also. We'll talk about that in the call flow. And we have certain kind of information that is being provided about the network to the user through all these different grids. The location and the position of the initial signals and the channels, which is the broadcast or the synchronization, is fixed. And the reason is obvious, as we talked about. UE wants to decode, first of all, this information, and he should know where it is present in the grid. Okay, we know about the multiplexing. Just a quick recap for all of us here. So we are saying that, we are using orthogonal frequency division multiplexing. Why do we use it? We want that all these subcarriers we are talking about, they are orthogonal to each other. It means they can transmit at the same time so that they don't interfere with one another. That is what we want. We don't want that, one subcarrier will transmit and it will create an interference for other subcarriers. So we don't want that. For that, we have this kind of multiplexing technique where we can simultaneously send all the subcarriers. When the one subcarrier is at its peak of amplitude, the others will be at a zero amplitude, so it will not interfere. So that we are using this complete spectrum band, whatever is given in 5G is more efficient way. And what we are seeing is all these boxes, what we have seen, we can allocate them to different users. So there is no kind of fixed criteria like, for a particular slot, for a particular subfrequency, we'll just keep it for one user. So that is not the case. So that is even more flexible approach we are taking whenever we are sending the information over there. Modulation, we talked about it earlier. So modulation is a very important thing. What we are trying to do is how many bits per symbol. Now, if what the symbol is basically in a time domain, this is the symbol we are talking about in a time domain. This column, one column is a one symbol. This is the OFDM symbol. So what we are talking in a modulation, how many bits per symbol we are sending. So how many bits we are sending in these boxes in a PDSCH. If it is higher, if it is more, obviously we'll get a higher data rates. If it is lower, we'll get a lower data rates. But how it is being defined, okay, let's look into that. So what we are saying is, and another part of the modulation, another beauty of the modulation is if we don't modulate the signal, if we simply send the carrier signals as it is, the kind of voice signals as it is, we can't transmit it for longer, or we need a very large antennas for that. That's why we need to modulate also. But when we are modulating these signals, we need to ensure that we are sending more bits per symbol. And we have a different categories for modulation in that case. If we are sending more bits per symbol, we are going up high on the on this ladder from QPSK to 16 QAM to 64 QAM. We have a 64 QAM as far as in 4G widely used, as going towards the 5G. If you see the kind of efficiency we are adding up, is we are sending more bits per symbol as compared to that in 4G. That is what kind of advancement that is happening. But it is not only depending upon just having that license or a feature in the network. Our radio conditions should be good enough to have these kind of more higher modulation schemes to be enabled in the network. Okay, coming back to the call flow now. So what kind of different procedures that happens when a user wants to connect to the network? So maybe a user is connecting first time. It means when the user is switched on. Second is maybe user is moving from one tracking area code to another tracking area code. So it has to register again to the AMF that, I'm now in this particular location. Next time you page me in this particular location rather than the previous one. There is a periodic registration also. Our device continuously, even if we don't use it, maybe we set some timer, maybe 2 to 3 hours. It keeps on updating its location to the core network, to the AMF in that case. So this particular registration is termed as a periodic registration. And the fourth one is the emergency services. Even we don't have a coverage, but we want to make an emergency call. In that case, this kind of registration comes into the picture. Now, the call flow. the first thing which we are talking about here is initial access. So we switch on the phone. So we are talking about the first one when the device is getting switched on. So let's understand what happens when the device got switched on. So now why it is important to understand the previous section which we just talked about. So in the downlink from the base station, from the cell site, there are certain information which is continuously transmitting in the downlink. And we understand the broadcast channel is there always, which is actually carrying the carrier bandwidth, the information about the network, which is relevant and required by the user. Now, this information is encapsulated in certain channels, which we have seen in a grid, which is fixed PSS, SSS, PBCH, that is fixed. So UE will decode these information to actually understand what networks I'm getting the information from, and am I belonging to this particular network? So he'll get all the information about the PLMN identity, what are the different criterias that are set in a network for user to connect to the network. So you may understand what could be this criteria. So say, for example, you are switching on the phone, maybe at a cell edge where the coverage is not really great. But how could we define that, what could be a good coverage to connect to that network? So we have that settings in the network, which is being transmitted by this particular channel in the downlink through the SIP messages. So once user will receive this information and see that, okay, this particular signal strength, what I'm getting right now is better than the threshold, which is defined by the network, then only I can latch onto it. If it is below that, I'll not be able to latch onto the network. So, okay, the first thing is just in a downlink, it is getting synchronized. It is getting all the information about the network regarding the PLMN, regarding the coverage signal strength threshold. What about the uplink? So we have a preamble which is coming in the uplink from the user, and this preamble is basically about calculating how far they are. And for that, they are using the term timing advance. And why do we need that? Because how far the user, if it is too far off, probably it has to start sending some information before a certain time period so that it can reach out to the base station appropriately and remain in synchronization. So we have certain kind of response coming from the base station to the user, okay, this user is this much far off. We should have this much of lag. We should send this information in a little bit of advance. We have a timing advance for that. How many resources that can be allocated? What is the identity, temporary identity of this particular user? All this information is captured and encapsulated going towards the user. Now here, RRC, that comes into the picture. Now, if you go back to the protocol level, which we talked about in a RAN part, so RRC is the main protocol which we actually analyze and see. We don't see other protocols whenever we track these kind of logs or capture them either through the drive list logs. We only look into the layer 3 messages, and these layer 3 messages is more about connectivity towards the network. So the first message which comes in the uplink, once the synchronization is happening, it is already done. Let's then get this kind of RRC connection to be built up between the user and the base station. Now, interestingly enough, if you see so far, nothing is happening with the core network. The user has not yet reached to any of the node in the core network. Everything, whatever is happening, is just between that cell site and the user equipment. That's it. So here, whatever this particular all this handshakes that have been done, it means the user, the network has given all the information to the user has been given all the information to the network, how far it is, they are synchronized, then what kind of identity the user is having. Once this all done, now the user is going towards the core network, and the first thing it comes is a NAS signaling which goes towards the core network. So RRC, what is happening is just at the radio level. The protocol which is coming into the picture towards the core network is the NAS signaling. Now, the NAS signaling is when the registration request goes towards the network, and this is where the authentication will happen. But before authentication, there are so many other things that have already been happened, but that has happened only between the device and the base station. Now, once these 6 different messages have been transacted, let's go to the registration request, which is going towards the AMF. AMF, we understood, it will authenticate the user. It will check all the different subscriber related information with the help of other two different nodes. Again, no need to remember the name of those nodes. It's fine. You just understand, there are two more nodes which is having the information about the users and its subscription. And once that all different authentication vectors are checked, the AMF will say, okay, we have checked your identity. You gave me your identity. We checked it with the AUSF and UDM, and we found that you are a legitimate user. You are authenticated. Okay. Once it is authenticated, it'll go to the PCF for some other checks, which is more about if it is in roaming or say, for example, the user is being allocated with certain kind of some certain kind of profile where he's eligible to use only 100 GB of data, just assuming it. And just PCF will check, if he's in roaming or he has already consumed all the data, what is that he has been allocated for. All these checks would be made here at this point in time by PCF. And here, basically, whatever SMF is doing is it is providing those. It is retrieving the information from the UPF, but it will not make a session yet, because session will be made only after the registration. So here it is just updating any of the PDU session which it is carrying earlier, and then it is saying that all the checks have been made at the backend with all the nodes. Let's accept the registration which is coming from the user, and there is a message which comes as a RRC connection reconfiguration. So whenever we see in the network, there are two different terms we see. One is the RRC idle and RRC connected mode. So RRC idle, in which the user, if it is in idle mode, it means it is only up till point number 6. It means user is connected only to the base station, but no to the core network. And why do we need that? We need that if the user doesn't want to have multiple transactions with the network, and he doesn't want to use any services. I don't want to use these many nodes for this user if he is not using any kind of services. I just simply keep him up till point number 6 once the registration is done. So that term is known as a RRC idle. But after all these authentication, registration, acceptance, connection reconfiguration, what we call it as a RRC connected mode. And once it is RRC connected mode, it means the registration process is completed. So this is the first part, which is getting all this checks to be made and the authentication to be done. That is there so far in the initial access procedure. So I'll just simply again show it in a simple way. The registration request comes to the base station. Now the base station, here we are selecting certain kind of PLMN ID. It'll give the information about the last visiting area code. It'll give the capability about itself. The user will give all the details to the base station, and then base station will check, this particular user with this particular temporary ID, should we register it or not? Then request will be checked with the AUSF and UDM in terms of ensuring that this user is having is legitimate. So once that is done, there will be different messages that keep on transacting between these different nodes for policy. Then after, there is a message when there is a PDU session which will be managed for this particular user by the SMF. And once the registration is accepted, it will say that you asked for this particular service or particular slice, and I'm configuring that particular slice for you. So now once the registration is accepted, what you can do is you can use this slice. If it is for broadband services, you can use that kind of PDU sessions. You can make that PDU sessions, and you can do those kind of traffic transactions between the network and yourself. So it's more about the initial registration whenever the device gets switched on. I know it's really very tough to get everything in a one go, but please feel free to ask if you have any questions so far here on this one.
Hello, sir.
Yeah, hello.
Hello, sir.
Hi, Malik.
Am I audible, sir?
Yeah, you are. Yes.
Yeah, sir. Sir, is it the minimum requirement required for simple voice call establishment also?
So requirement would remain same for registration, either it is a voice or a data, whatever we just talked about. So it'll be the same. These are the minimum steps which needs to be taken care of.
Then, sir, you just mentioned till RRC we can go and stop their RRC setup.
Yeah.
I mean, till 6th. Till 6th,
Yeah.
what exactly it means, sir?
Yeah. So good question. So basically what we do is we have two different kind of states, which we call as a RRC idle and RRC connected. So in that case, till here, the network doesn't know the location of the user at a cell level. So network will say that when I say network, it's a core network. So core network will say, I don't have an exact location of this particular user, but I know that he's lying in a particular geography in a location area code. So I'll page it. Whenever something comes to him, I'll awake him and I'll give that information to him. But he doesn't need to go through all these things at that point in time. Where it helps where the network, say for example, many of the users who doesn't use the services for maybe a couple of minutes or maybe half an hour or so, it is just, we kept the phone aside. Now 5G, the overall ecosystem is so smart. They say that you're not using these services. Let me just put you in idle mode where I know your location just in a particular geography. That's it. I don't know in which particular cell you are located. In that case, what is happening? I'm saving my resources on doing all these things with each and every user in that case. So say, for example, I have maybe 1,000 users in a particular location area, and my AMF is maybe loaded. In that case, if I keep on doing each and every user, keep on doing all these things, if they don't want to leverage any service at certain point in time, so I'll just put him in an idle mode, and I'll say, I know you are in a particular geography, you're in a particular location area code, but whenever something comes for you or you ask for something, I'll get all these things set up for you. But if that is not required, I'll not give these kind of resources to you, because that is just a wastage of resources for AMF. That will be a signaling load for that. So that is one part. That is RRC idle mode. After that, whatever is happening is when somebody wants to start using the resources, start using the services, then these whole process will happen for that particular user. So we keep it in user in a idle. In 5G, there are three states basically. One is the idle, one is the active, one is inactive state. So these states are just to make these whole operations more efficient. That's it. Now, when it is coming to a voice or a data, whatever the call is, they have to go through whole process. So there is no escape for that. It is just to making this whole ecosystem more efficient. If you don't use the resources, just sit in idle mode. Don't consume my resources. That is the only concept behind it.
Thank you, sir. Thank you very much. Yeah.
Welcome. So as I said, it is in a one go. Even somebody tells me or teaches me, I'll not get all these things in one go. But what I would suggest is just try to correlate it with the fundamentals rather than just understanding the AMF, the PCF selection and session and all these things. Try to correlate it with things like, okay, if my device, it is not necessarily to connect to the AMF all the time. It will be connected if it is to be getting maybe moving out from one geography to another geography. Maybe it'll be connecting when I'll ask to access certain services. But if not, then I'll sit in an idle mode. So those are the different kind of procedures that are there. Now, in case of, so this is what we have just talked about is the initial registration. And we talked about after that, user can be in an idle or it can be in an active state. When we say it is an active state after the registration, this is what happens basically when we ask for certain kind of resources. When we say the PDU, it is a packet, the packet data units, which is basically, it's more about the getting the actual data to be flow now. So if we have seen earlier in the grid also, we were having certain slots or the source elements which were allocated just for having that initial setup to be done. And then we have a PDSCH, which was the share channel, which was actually carrying the user information. And that is where we are actually carrying the PDU or making the PDU sessions and transmitting and receiving the information bits. Now, in that case, also what happens is there is a session request. If this user wants to say that, I want to make a voice call or I want to make a data session. Okay, that session, there is a request which is going to the AMF now. And now the AMF will check with the SMF for this particular PDU session request. Then there are different messages which is going in between. No need to get into that, but what is saying, okay, this is the request which is coming. We have a user subscription data which is there. Let's see that what kind of service you want. If you want, say for example, a lower latency services, okay, there's a kind of session which is required for lower latency services. But for that, it'll get certain kind of user information from the UDM where the authentication would happen. So far, again, the authentication has to happen again for any particular new use case or new services. In that case, PCF it'll be in the picture, but now the SMF is the one who will check that which UPF to be selected. Now, when we say which UPF to be selected, there is a possibility that in network we have multiple SMF, multiple UPF, multiple AMF. But how do we ensure that which SMF to be selected, which UPF to be selected? So AMF will finalize that, okay, this is the SMF I want to connect to. SMF will finalize, okay, this is the UPF I want to connect to. And once they keep on connecting, they keep on telling the information that is being received or requested by the particular user that this is the session we want to make. This session could be related to broadband, could be related to low latency, could be related to machine communication. But this session, this is being requested by user will pass on to each and every node here, AMF to SMF to UPF. And then the UPF is basically, saying that, okay, we can provide this particular service to this particular user. And once this request is being the PDU session request is being authenticated by the network, then there is a kind of actual data that will start happening in uplink towards the UPF. So this is the after having initial registration, whenever there is a kind of service which is to be availed by the user, these different messages keep on happening. But important part to understand is what are the nodes that comes into the picture. And these are the few nodes which you need to remember, because when you open up a core network architecture, maybe in a 3GPP, you may see 20 different nodes talking to each other. Probably that is a kind of it's not an easy illustration to get through those kind of architecture pictures. But here, simply understand, okay, you got information from the user, somebody has to authenticate, somebody has to ensure there is a policy configured for that. There is a one device which will ensure that which particular user plane function you need to select, and then the information will come back once it is authenticated from those nodes. So this is how the user plane then start, establishing between the user and the network. Okay. We are 11:42 now, my time. We are mostly at the end of this session, but this is basically about why we are talking about 5G too much, why everyone is behind, talking about 5G technology, because there are different studies made by different organizations, and what they are saying is there's a huge potential in growing the economy. Why Prime Minister is talking about 5G, 6G technologies? Sorry, somebody wants to ask something?
Sir, I have one doubt.
Please.
Sir, in the last slide, the final connectivity is done to the data network or the internet.
Yes.
So you mean to say that the particular SMF or UPF or AMF has been selected so that either URLLC or EMBB or MMTC, that particular use case has been realized when it connects with the internet. That's the meaning to say?
So it can be, it can be sometimes a server also. Say, for example, MMTC, it is a manufacturing unit, say, for example, and they have a particular server which they want to connect this particular device to. So this is just an example where in that case, it could be UPF will be directly connected to their server, which is on the cloud, which is trying to get some information from the cloud. But yeah, it can be for voice services. It can be IMS also. This is just one example.
Yes,
but
sir.
it can
Many
be
other
a different.
services. Yeah, got it. Sir. Got
it can
it.
be
Thank
different.
You,
Yeah. Yeah. So when we are talking about the economy, the potential that is there by leveraging 5G, what the studies are saying is there is a huge potential in adding up around 1.3 trillion USD dollars to the global economy by 2030. And though we can see, the India is somewhere at number 4th or 5th, But the kind of expansions that are being done in India in terms of evolving technologies in telecom is really remarkable. We have seen, I think, the fastest rollout in the last year in India in terms of 5G. So I mean, there is a clear focus of different countries to leverage 5G through different industries. But right now, what the hiccup is, the 5G, we are still using it widely for same conventional kind of services, which is human to human widely. If you see, it's for voice or data. But what everyone is trying to get into is going towards the enterprise kind of ecosystem where industrial 4.0 revolution, where different companies in, say, in manufacturing, healthcare, utilities, they will start leveraging 5G and start creating some kind of value. So this is what these different studies are saying. There is a huge potential of leveraging 5G, like in healthcare, out of this economy, which is being, forecasted. Around 40% of that can be generated by just healthcare. Around 25% of that can be generated by smart utilities, be it electricity, water, whatever. They can leverage 5G and they can just make more efficient kind of utilization of resources. Imagine if kind of there are certain sensors which can imagine or which can forecast, you just need these kind of supply in these particular areas, and that can, or in case of electricity, if there is a kind of forecast that, in winters, this is the kind of consumption that's going to happen. Accordingly, these industries can then prepare according to that, and rather than just over forecast or over provision their capacities, they can optimize them and save on energy as well as the profit margins also. So these are the different kind of industries where 5G can be leveraged. In case of use cases, widely, if you see, the around 66% of the use cases would remain be the data services, like the broadband services, be it a fixed wireless access or be it a EMBP. Around 33% of the use cases, around 50% belongs to lower latency and massive machine type communication. So this is the study which gives us an idea, connecting the dots, like what we are talking about in technical world, how it's going to help in a overall growth of the GDP globally. So there's a huge, massive impact. So whatever you guys are doing, it's amazing. That's what the impact is going to be in the coming years. So yeah, this is the last slide. I may talk about, the platform which I built, but if somebody has any technical question, I'm more than happy to answer that. Please feel free to ask. I can understand we have quite a large amount of people here, but please feel free to just message me, ping me, talk to me if you have any questions. I'll share my details later on. But before winding up, I'll just take 5. Yep, please.
I think one Mr. Aditya has kind of opened his mic. Aditya, do you have any question?
Sir, good afternoon, sir. This is Dr. Nagamani from University of Hyderabad. It's my son's name. First of all, I'll thank you. And it is a wonderful pictorial information, lot of information. That's why we are unable to ask the question. We have a lot of questions rising, but there's a lot of information we are not able to understand. The first question, sir, actually, this 5G technology and the data transmission day to day, the technology is improving. And most of the countries, they are saying that, no, India is taking still 5G technology. We are moving 6G technology. As though Ashok sir has explained well why we are a 5G technology and what way our Indian languages context, this 5G technology is useful and helpful, and still we are in sustainable manner kind of thing.
Yeah, I mean, I think he's right. So, and I must tell you, I'm working in UK, so we are not in UK also. I don't see like it is far ahead of India. I mean, we are at par, I must say that. And as far as the kind of capability that we have in India is tremendous. The kind of rollout, as I said, the last year, I think it is one of the biggest rollout across the globe. And it might have surpassed the kind of penetration we have in 5G in India as compared to other developed countries, some of the developed countries. So yes, we are very much in the forefront of evolving these technologies in the ecosystem in India. And let me tell you that the 6G, whatever is being talked about right now, it's more about theoretical part. I was in Berlin last year in Germany, and we're talking about the 6G evolution that is happening. And still, people are still trying to understand it because we have not leveraged the 5G to the max extent yet. As I said, we are just using everywhere, even in India and in UK and whatever. We are using it widely for the data services, for the broadband services, but we haven't yet being able to leverage these kind of use cases which we are talking about, where we can club the manufacturing, the enterprise units, help them create some value for them, and then improve the overall GDP. I think this is where still all the industries they are trying, be it manufacturing, financial, consumer, whatever, and trying to have that kind of association with telcos to create some better efficiencies in the ecosystem. So yeah, I think but I must tell you that India is forefront, is in the forefront of technology. I think there's no doubt about it.
Sir, adding to this point, question is that, is it the geographical aspect or technologically the people are, maybe I'm not pricing them, yeah, technologically they are in core and knowledge wise somewhat rich, so that sustainability condition they are good at using the technology, still we are progress in 5G technology in India. Is it?
So are you talking about the skill set, or are you talking about the end consumer who's leveraging 5G?
Sir, end user point, no doubt India is the foremost condition kind of thing.
Yeah.
But in sustainable technological usage context, that is developers context kind of thing, and also geographical condition of India, the maybe is also supporting. Can we think that way?
So you are seeing the sustainability of the technology in India. I mean, how we can make it more sustainable from climate perspective. You're saying?
Yes, sir.
Okay. So I think there are some drives that are being happening in India, and I think everywhere to just make the technology more sustainable. Like I think Vodafone has pledged something that they are going to be net zero by 20. These kind of targets to make a sustainable, development in technology. So India is at par, I think, in that case also, because the thing is, it's the same vendors, same ecosystem, which is in India, which is abroad, which is everywhere else. I don't see there is a challenge for India to have to stay behind of these kind of evolutions, or in terms of sustainability also. So I don't see any kind of challenge for India in that case.
Because most of the time people are saying that already foreign countries are moving 6G technology. There is no scope for 5G technology. This was a little there is fear point and also hype kind of thing. This that's why question.
No, I mean 6G is nobody. I mean, somebody can say that the 5G, they are not able to yet leverage it to 100%. But 6G is nowhere in the picture. I haven't seen anyone has deployed 6G yet, and there is no point in the basics are basically whatever we have talked about in terms of evolution of the architecture. Be it 5G, 6G, 7G, whatever it will be going forward, we have to evolve those. We have to set those basics right. We have to make an ecosystem which is good enough to incorporate any technology quickly. That's where we were talking about, the architecture. We are saying make it more virtualized. Make it more virtualized. It means, we have a box which we can use for one technology today. We can use it for other technology tomorrow, the same unit. And that's what's not happening today. And it's with everyone. So those are the basics which we need to set right first, be it 5G, 6G, whatever. But I mean, in a way, if you ask me that 5G is a failure, if that is your question, so I will say no. So, or 6G is a success, no. There is no, right or wrong at this point in time, or failure or success at this point in time. But yes, the important part for telcos right now, look at from the operator's perspective, I can understand, there's a huge pressure in actually getting the revenue according to what the investment they are making, which is missing right now. Because 5G, if you look from the customer perspective, if I'm a customer, you're a customer, you don't give it a care, give it a damn, thing that, okay, I'm using a data services, be it 4G, 5G. I need my services to be working fine. If I'm watching a video, if it is on 4G, 5G, it doesn't matter to me, isn't it? But when operator says, I've launched 5G, can you pay a little bit more for this? Customer will say, no, I'm happy with the 4G. I don't want to pay you more. Why do I pay more? I want to stream video. I'm streaming video. So these use cases are okay with the 4G as well as with 5G, but maybe going forward when it is AR, VR kind of scenarios, new use cases will come up, maybe enterprise use cases will come up. Then in that case, there is a distinguish between the 4G and 5G. The customer will be happy to pay more. But yeah, I mean, I can't see like 5G is yet fully evolved or deployed yet. Even any country you see, I don't see that it has been deployed to the max extent yet. So it's a long journey. Thank you.
Because
Yeah.
my question is
Interesting.
for the researchers who want to take up the researches. Your answer is really impressive, and they have a opportunity for them to look into the 5G technology researchers.
Yeah.
Because otherwise people will have some conception that, okay, it's not going to be sustained. So people won't take, because research is 5 years or 4 years, they have to work on this problem.
Okay.
And your
No,
explanation really given an opportunity for us. Thank you very much.
No, thanks for the question. I think it's really interesting from research perspective. Yeah, keep doing because anyways, the legacy technology is the base for the next technology, and try to leverage the new things like open architecture, the machine learning and AI part, which is really interesting. And you can reach out to me anytime, any of you, to talk about all these things. I mean, I'm working on right nowadays on machine learning part also, so we can always talk about how we can add more efficiency in the network. Right. Okay. So maybe last.
So
Yeah.
there are two more mic on, Dr. Mallikarjun and Dr.
Yes,
Bilal. So Mallikarjun, sir, please go ahead.
Yeah, sir. Sir, how exactly the 5G and 6G technologies can be realized for getting our precision agriculture done?
Okay, so that's an interesting question. Again, when it comes to a particular segment, you're talking about agriculture, right? So there can be many different use cases how we can leverage maybe drones in that case too, or maybe different kind of scenarios where we can it's more industry specific, but what I'm thinking is from 5G perspective, it's more about getting more information, more data from any particular place where agriculturists would like to get insights about how their the ecosystem is growing, or how their farming is doing good or bad, or with time, maybe by having some visuals from drones, they can observe that this particular whatever they are growing, it is doing good or not by images, by time to time analysis. But frankly speaking, industry level, of course, there is something which telcos and these people have to sit together and figure out what they want and what telcos can do for them. Because at the end of the day, telco can give only connectivity. But it is not only about the connectivity. Some applications can be made where the tracking of how their once the seed, once how it is growing, how it is flourishing, it is doing good or not, how much water they need, what kind of sand soil it is. I'm just throwing an idea, but there could be a multiple ways where the connectivity can help to create certain kind of application use cases where they keep on tracking all these things time to time. And yeah, that's what I can think about. But it's more of having a detailed analysis, I would say. Yeah, but
Then,
agriculture,
sir,
I'm really.
yeah, sir. Then how 6G is much predominant over 5G, sir, in so to say?
Yeah, that's what I'm saying. There is no, frankly speaking, if you need 1 Gbps, why do you look after some other technology which is giving 10 Gbps? It doesn't make any sense, isn't it? What 6G is going to do is more, it's still in a developing stage. And it's not about just a buzzword, there should be some kind of efficiency or some kind of use cases, some kind of value that can be created by these technologies. That's what we are seeing with 5G. Say, for example, as we are going towards IoT, or we are going towards some kind of application that can be generated, which can help to have a use cases with the lower latency kind, as I talked about the automobile industry. Similarly, 6G is, first of all, let's understand what 6G is all about. It's even stringent deliverables by 5 as compared to 5G. But we are still not able to reach that 5G deliverables, isn't it? And we are still not able to leverage it. And in case of agriculture, I mean, you probably don't need a low latency of 1 millisecond, isn't it? So 5G is more than enough for most of the use cases. I think 6G will come when there will be a use cases like you have a hologram kind of a scenario, you have a kind of the AR VR, which is very advanced level of use cases in that case. But I think, or I don't know, but at this point in time, I don't see much of the use cases for 6G, and it's not actually mature. It's still in the books right now. So yeah, don't worry about
Yeah,
6G yet.
yeah, sir.
But yeah,
Thank you very
keep
much, sir.
if you are
Yeah.
in a search sector, but keep doing it. I think, but I'm talking about more about the practicality or the deployment aspect at this point in time.
Okay, sir. Thank you.
So
Yeah,
Dr.
okay.
Bilal has raised hands. Dr. Bilal, please go ahead. Dr. Bilal, your voice is not coming. So I got one question on WhatsApp, like his mic is not working. So his question is from Mr. Chetan. He says that
Mhm.
how UV will be selected in a cell-free scenario.
So I just want to understand what is cell-free scenario. I'm not. So when user is selected in.
So he's talking about like a cell-free network. We are talking about, no, that there will be n number of kind of transceivers, base stations, and the concept of cell-free he may be talking about. Anyway, that was not our topic of today's, so we can
Yeah,
skip this question. Yeah.
yeah,
Okay.
yeah. But
Any
anytime.
yeah. Any more question from anyone?
Yeah, I mean, if they don't have any questions, I mean, they can. Of course, we can talk about the platform
So
which they can always reach out to.
and secondly, if you can, I mean, so one point is that like all our participants are from engineering colleges, and
Right.
you are kind of providing education related to technologies, telecom technologies. So in
Yeah.
case any of the institutions may like to collaborate with you for any training and all, so how to go about with that information, you can share a little bit so that
Yeah.
they can reach out to you in case they need any of it. Because I understand that not every institute will have the faculty on all the topics. So maybe they would need help of the institutions or organizations like yours. So how they
Yeah.
can make use of your expertise in this area, if you can tell us about that.
Yeah, sure. So, whatever I've just talked about, it's just maybe 1% of what we have in our learning platform. The learning platform is ITELCOTECH. So I founded it like 2 years back. Whatever the learnings I had over the 2 decades and with some experts, what I tried to do is I just kept it at one place. And we are trying to cover, various topics about the technologies, maybe it's 4G, 5G, even the 6G, a little bit about that. or maybe about the different, the components of the network. We talked about the core network, we talked about, the radio, the transport, but you want to get into more details. We have a specific, even for the satellite communication, we have a specific kind of content that we have captured in our platform. And what we are doing is basically we have around almost close to 4,000 learners across the globe right now. And our courses are best-selling. And what we are trying to do is we are trying to cover the vast content right from the beginning to the intermediate or to the experts, and especially when for the students who are right now in a year 3 or year 4 of their graduation, I think it's important for them to understand how the real world, whatever we are learning today, how it is actually implementing or being implemented in the real world, which is more important to understand. If I imagine myself, it took me at least initially 3-4 years to just understand the basics, because nobody tells you until you go to the site and just look at the things, to learn about it. But the good part today is, we have many details. Like Ashokji has so much, great content on the platforms like social media. Similarly, I try to make certain different concepts very clear in an easy and concise way. So be it related about, the basics, how the mast looks like, how it works, what these protocols are, how the network looks like. I have captured some real world videos from the sites, how it looks like, how it works, and right from the basics to the advanced level, we are trying to cover it. We are also talking about the machine learning and the AI in telecom, because that is something which is really interesting to understand going forward for everyone. That we can, in an IT domain, if you see, we are way behind in the telecom as compared to the IT, because we are not leveraging these kind of the open sources and machine learning kind of capabilities today. So in our courses, we are trying to just cover right from the basics, maybe to the protocols, to the call flows. How do we make it more efficient? The networks or the technologies, we can make it more efficient. We have all these different content that is there in the website, and I'll just quickly show you. I mean, you can reach out to me or Mr. Ashok anytime to get some more details about it. But you can reach out to me at my email ID. You can take a snapshot of it, and you can connect on the LinkedIn. I'm there, so it's easy to recognize, because I'm most probably very few. My surname is very unique, so I might be this name must be very few in the LinkedIn. This is the website you can always go through, www.itelcotech.com, and you can reach out to me on my WhatsApp on email ID, and we can always talk about it. If you have any technical question, you can reach out to me again, to Ashokji also, and we can always help you with that. So yeah, thanks for giving this opportunity. I would say thanks for being so patient. For me also, it is not easy to speak continuously for 2 hours, but I would like to have these kind of sessions, the interactive sessions live, where we can see each other, we can talk to each other. It's not only about just technologies, it's about understanding the overall ecosystem, how things are working in the other part of the world also. So I must say thanks to each one of you to being so patient, and to Mr. Ashok for this opportunity to come across you guys. And we may have another session also apart from this. Yeah, that's from my side. Just stop sharing.
Sir, can I ask last question?
Please, why not?
Sir,
I think Ashokji, you are on mute.
Okay, what I was saying that Dr. Bilal has raised the hand again. So before ma'am says anything, Dr. Bilal, are you able to speak now? We are not able to hear you, Dr. Bilal. There seems to be some issue. You can WhatsApp me your question so that I can read it out. And maybe, yeah, no, Mr. Anil has also raised. Mr. Anil, if you want to say something. Anil?
There was one lady who was trying to ask a question.
So maybe, ma'am, if you want to say something.
Sir, regarding this educational, the collaboration kind of thing. Now India is promoting NEP 2020, the university level, the open elective courses. And as Ashok sir knows that India is also giving this 100 labs the opportunity for learning these things. in this context, maybe with the concern of Ashok sir, we can float one university level course in this 5G technology as an open elective course, so that the universities and IITs or engineering colleges, anybody can opt this course kind of thing. If that kind of proposal, because I never find any FDPs or this thing, this much informative and knowledgeable sessions, and really thanks to the Ashok sir. If this course is reaching to everyone, the student, it will be beneficial for the industry as well as the academic kind of thing. Maybe this just a question.
So thank you, ma'am. I'll just add one thing for your information that AICT has already included a semester-long elective on 5G technology, and the course content is similar to what we are trying to cover in this FDP. So from AICT point of view, they have already prescribed. So now question is that which universities are able to launch that particular elective course? That will depend upon how much resource you have in terms of labs, etc., and also the faculty. So that enablement has happened, but real fruit or real start of the course, perhaps now it's a time to start. Now I'll request Anil to. Anil is my colleague here at TOT headquarters.
Thank you, Ashok.
So Anil,
And
yeah.
thank you. I hope I'm audible. Thank you, Ashok. Thank you, Rahul ji. It was, I mean, for somebody like me who understands very less of 5G, it was actually very, very learning to us. Thank you very much for being so patient with many of us. I just got last line which you said you love, you know, interactive, and when you can see us face to face. So we have this India Mobile Congress from 15th to 19th October. I am just making a formal request through Ashok and directly that you just see if you will be able to travel to India during that period. We will work out everything, and we can make sure that 70–80% of the faculty members who are here are part of the session when you can come and deliver, you know, 1 or 2 sessions. Because that has multiple streams and multiple halls, so we can work out and dedicate one hall for 5G learning experience, and we can make you know, benefit from experts like you. So just see, we'll work backwards. I mean, 15th to 19th October. If you can be in India at that time, we'll be very, very happy to give you a platform and work out other nitty-gritties of your travel and everything. Okay.
Yeah, of course. I mean, let me just think about it, and of course we'll try to work out. But thanks for the invite. Much appreciated. My pleasure. I'll definitely try my best to be there.
So thank you, Anil, for this offer. And maybe I'll give your coordinates to Mr. Rahul so that.
No, I'll talk to you only, sir. I'm sorry to be. I'll talk to you only. I mean, I can reach out to him. He has shared his LinkedIn profile, and it's a very good, you know, very discreet kind of a surname, so one can find him out. But still, I'll reach out to you. I'll not bypass you, sir. Okay.
Yeah.
Thank you.
Okay.
No, thanks a lot.
Thank you. Thank you very much.
So I think we have already taken more time from Rahul ji. So so thank you so much for being with us for today, almost 3 hours now. So now we will, I'll request Sanjay for a formal vote of thanks. Over to you, Sanjay.
Yes, sir. So, eminent speaker Sri Rahul sir, Sri Ashok Kumar sir, and participants, on behalf of entire team and participants, we extend our sincere gratitude to the esteemed and knowledgeable speaker Sri Rahul Kaundal. Your profound passion for your respective field and your dedication to share your expertise have ignited inspiration within us to strive for excellence in our own pursuits. Your presentation was not only informative but also provided profound insight into the topic Your ability to offer a clear perspective and explore into intricate detail of 5G network, core architecture, 4G, 5G, frame structure, session establishment in end-to-end call flow, as well as leverage to economy were highlight of your talk. Sessions of a diverse speaker and a distinguished speaker like you, Rahul sir, has significantly enriched our content of our faculty development program. We eagerly anticipate more engaging learning opportunity in the future. We also would like to express our heartfelt appreciation to our passionate participants who generously dedicated their valuable time to make their session interactive, successful, and fruitful one. So thank you once again. Thank you all. Warm regards and Jai Hind.
So,
Thank you.
maybe before we say goodbye, may I request everyone to kindly open your videos so that all of us can see at least once.
Yeah,
So
it'll
may
be
I
great.
request
Yes.
everyone to, yeah, thank you. Yeah, so now we can see Dr. Bilal, who was trying to speak, but
Yeah.
I don't know, some mic issue. Yeah, thank you everyone for opening your videos also. So with this, we say goodbye to everyone. So thank you, Rahul. Thank you so much.
Thank
And
you very much.
I'll coordinate with you for the second session, which
Sure.
we have talked about. So thank you so much. Thank you everyone for
Thanks.
joining. Let's join back tomorrow. Tomorrow, what time, Madhukar?
10 o'clock, sir.
So tomorrow, 10 o'clock onwards, we'll have a session. So
Yes, sir. Yes, sir. We have session from VIT Chennai, 10
okay,
o'clock, 5G wireless network simulation in network simulator by Professor Vetri Velan,
okay,
VIT Chennai.
right. Thank you. Thank you so much.
Thank you, everyone.
Thank
Have
you,
a great
Rahul.
day.
Thank you, sir. Thank you
Thank
so
you.
much, sir.
Thank you, everyone. Thank
Thanks
you.
a lot.
Bye for now.
Thank you. Thank you.